Just going to the term nexus and trying to understand what we're talking about. If we look at the dictionary definitions of nexus, it doesn't really help us much. They're sort of very uninteresting. It's just things coming together. But I think in the scientific fields and in the areas we're talking about, it's something more than things just meeting. It's when there's really complex issues. It's the big, hairy problems, the vicious problems that have been spoken about. And from our perspective, we see it's very much when you have coupled social, environmental, ecological systems where there's very, very complex feedbacks taking place. And what happens in systems, and people that understand systems theory, is where you've got complex feedbacks, you often have unexpected outcomes. And again, looking at the sort of science behind this, it's often where you've got thresholds in the systems or tipping points. You need to be really careful that you don't go beyond what the system can absorb. And as we understand more and more about these environmental systems, we realize many of these systems aren't linear in nature. Often the responses are a non-linear curve. You can move around in the system within a certain area, but go too far and the whole system collapses. Also, when you speak to people about nexus, different organizations have different ways of what nexus means. There's clearly a whole developing field of science around nexus science. But some organizations, they just talk about it and say, well, we just need a nexus way of thinking. We need to just drive a more diverse way of thinking, a way of thinking that just starts to work between these different silos, starts to consider impacts in other sections. And then there's also clearly a whole lot of tools that are evolving, things like integrated assessment models happening at the global sphere to understand what the resource limitations are. It's very, very complex modeling processes, through to a number of things at the far more social side of things. Just simply getting people to talk with each other, obviously been very important, but often also bringing in different tools to aid people in talking to each other so that they can understand their different viewpoints and speak in a more structured manner. Just looking at a nexus view of the world, again, going back to these complex feedbacks and the unintended consequences. As somebody said yesterday, the requirement of energy provision in South Africa and water is actually quite small. I think they gave a percentage of 2% of our water was going to energy. And yet this isn't looking at the feedbacks and it's not looking at the long-term feedbacks. If we look at it, we thought we had a perfect solution to energy going back a century, maybe a century and a half. We tapped into coal, petroleum and such like. What we didn't realize at the time is that this would feed back into the climate systems. So what we're seeing now is, though we solved our energy problem, or we thought we'd very effectively solved our energy problem, the impacts were only probably 100 years or even further down the line. And the impacts now on the water sector, on the food sector, are actually not coming directly from the energy sector, but they're coming through climate change in a very, very complex feedback system. And this is one of the problems. We need to understand these complexities, and that these feedbacks often are very slow and come in different sectors. What we've done at the CSIR, particularly in the natural resource side, is found that talking about an environmental envelope, or the size of an environmental envelope, is actually quite a good way for us to internally think about some of these problems. So in other words, it's trying to understand what is the size of the environmental envelope in which we can conduct development, understanding partly how we can grow that envelope, get more for less in a sense, and then obviously the trade-offs have to take place within that space that's available. Obviously this needs to be evidence-based. We need to understand the tipping points. We need to understand where those critical thresholds are and not exceed those critical thresholds. And obviously there's a risk factor involved, and that's a problem with thresholds. You've got to buffer around them, and you've got to have sufficient buffer around them not to exceed the thresholds. Another thing that I think is very important is understanding the bounding of the system, and Patrick's talk just prior to this, I think, brought that through quite clearly from the water perspective. We can't see water just in terms of energy and food, but there's a whole lot of other needs for water as well. So you've got to grow the system bigger if you look at just water, energy, and food, you're missing many of the other components that are important. If you take it from a land lens, if you don't bring into play biodiversity, the importance of biodiversity for tourism, other land uses such as fiber, be it through forestry, cotton, sheep, etc., then you miss out on many of these other aspects of the planning. So if you try to maximize just for food, water, and energy, somewhere else the system's going to crack and you're going to lose out on other parts of that. And then also there's also critical climate feedbacks that we need to look in at. The other side of bounding that I think is very important when we look at Nexus issues is the spatial bounding. And many of the issues only really resolve at a global perspective. So if we're looking at food supply, if you look at food supply in the country, it's actually very easy to not meet national food targets. Provided you've got enough income, you can just import the food from elsewhere. So what you do is you just simply push the problem across the border into somewhere else. And that, even within the country, becomes a big problem if you're taking a Nexus approach, say at the level of a town, of a province, that many of the problems can be moved across. Even things like water, and again in the last talk, we're talking about moving water across boundaries as a way of meeting the problems and solving some of the issues. Then a lot yesterday again was said about sustainability and what we think of sustainability. And for particularly the older people in the audience, I think you've all sort of seen this view of sustainability. And somehow we are always sort of told in the middle there's this sort of magic soft spot where environment, social and economic all come together, and you get things in there and things are really hunky-dory. But the new way of thinking of sustainability has changed a bit, and I think this is largely driven by the ecosystem services type of approach, the Millennium Ecosystem Service Assessment. It's realizing that economy is actually embedded in social systems. So though I think many of our decisions are driven by economic decisions, it's a very, very useful lens to understand what happens. We've got to understand that economics is part of a social system, but more so, the social system is dependent on the ecological system. And a way of looking at that is very much the goose that laid the golden egg. If we lose the environmental system, we all know what happens. And in many cases, we can find solutions for this, but often the solutions are technical in nature and hugely expensive. So we lose the cheap solutions, go beyond those thresholds, and start getting into very expensive solutions. At the CSIR, we've been involved in a number of global assessments over the last year, or last 4 or 5 years, in fact. Some of those are the IPBES land degradation and restoration assessment, the Africa assessment, the 1.5 degree assessment. I think that results were just a week or two ago, and then also the World Atlas of Desertification. And I think there's two messages that come through consistently from all of these issues, all of these assessments. And the one is that the window is closing. Our chance to do something is rapidly reducing. And then the other thing that comes through on almost all of these is fixing the problem is way more expensive than the prevention. So just going to the 1.5 degree assessment, and this text comes, I think it wasn't the approved text, it's prior to the approved text. But two issues that seem to come out very consistently through it. A 1.5 degree future is way better for us than a 2 degree change future. We lose a huge amount by just that extra half degree change. But the other message that comes out very strongly is if we go for if we want to as a world go for a 1.5 degree solution, we've got to act very, very, very quickly. What they're suggesting is we need a 45% reduction in 2010 carbon emissions by 2030. In other words, that's just over 10 years away. We've got to halve our CO2 emissions. Just putting that in a graphic form, to do that, you need to literally stop carbon emissions right now, and by 2050 we have to be at a zero carbon emission state. that is hugely close. If you look at the sort of alternatives delay for about 10 years before we start reducing emissions, we actually then by 2050 need to be into a negative emission state compared. And so those are really, really scary issues to look at. And also, this obviously has a huge implication, for instance, when we look at our energy planning into the future. We're still talking about putting coal-fired power stations into our energy mix. Those often have a sort of 40, 50-year lifespan, and yet we're looking at a period 30 years away where we're saying zero emissions. You know, those are just quite clearly in conflict with each other. And just bringing this back to a sort of land productivity issue, this graph is based on JRC in Italy's research. They've taken long-term satellite imagery, looked at productivity based on satellite imagery, vegetation productivity. What we've seen in South Africa, and I'm convinced it's driven by climate change, is this whole sort of central part of the subcontinent. Productivity's dropped greatly. And what I'm thinking that's there is we've gone past a threshold. We've got way hotter in those areas. They're dry areas to start with. We've gone past a threshold that's dropped productivity. This despite other places like the eastern shore of the country where actually productivity's gone up. And that's one of the sort of issues of climate change. It does produce higher productivity in some places, but certainly center of South Africa, and that includes a lot of our crop growing areas are looking like they on a trend to a very unstable future. At a global scale, we've seen major trends in where resources are being used. This is what's called the human appropriation of net primary production. It's a measure of the primary production that's expected in the area versus how much has been used by humans. Some really key hotspots, particularly the India subcontinent, but South Africa, Europe, and other places also not looking that healthy. Clearly, climate change is one aspect of a future. We need to bring climate change into any future, any Nexus planning, but we also need to look at other drivers of change, and obviously human demography is a big change. If we go back sort of from I think that started off in the 1950s through to about 85, we had a population that was evenly split rural and urban. We're looking at a future where the rural population is a very small component of it, huge urban populations. This changes the whole sort of dynamics of where water in the country goes, where food in the country goes, etc. So we've got these huge sort of sinks of food and water in the urban centres, obviously having to be sourced from the rural sectors. And this changes the whole sort of way we need to conceive and plan around Nexus issues. Also, as I was saying earlier, these issues also go way beyond just the food and fuel. For instance, are going to climate, health issues, air quality issues, etc. Changing tax now, just a quick case study of where we've been trying to look at some of these issues, and we've had a fairly long project in Swaziland. Swaziland's a really nice, simple case study. There was a diagram in the last presentation about some of the water systems in parts of South Africa. South Africa is just really, really complicated to try and resolve some of these issues. So we've been looking in Swaziland at some of the sort of fairly easy things, looking at climate change, the impacts of climate change, particularly on water availability and how that reflects on water demand. And they've got a very simple sort of dichotomy there. They're either using water for subsistence type maize production, or they're using it basically in the downstream areas in high, very modern, some of the most modern sugar production globally. And this makes also a nice case study because sugar in that instance is a huge driver of the economy. I think where agriculture is about 3.5% of the South African economy, and that's including forestry. In Swaziland, just the sugar industry is driving about 16% of the economy. But there's a whole lot of problems happening there. One is that the country is a food insecure country, so there's a question of should the water be going to sugar driving the national economy, or should it be going to driving local food security? Clearly, there's climate change impacts happening. What will this have on the production of both the food and the water? And then there's also changes in the global markets. Sugar used to get huge subsidies from the EU. Those subsidies have fallen through. Basically, the sugar price has halved in the last few years. However, things like the fuel prices have gone up, and one has to start asking, should they be keeping growing sugar? If they do keep growing sugar, which they're able to do very effectively, could that be going into different markets, such as the fuel market? Just on issues we're looking at there, the one is the water availability. How much water is available in the catchments, and how will that change as climate change takes place, obviously taking consideration of the land use in the catchment at the time. Also then the water demand of agriculture, 2 or 3 degrees hotter, that changes the evaporative demand. Certainly there are some CO2 compensation effects, as was pointed out yesterday, those change by crop. But we assume that in the future, the water demand from the different crops will be different from what it is today. Part of that can be mitigated through changing of irrigation systems, but the area under sugarcane will probably change in the future purely as a consequence of availability of water. And then obviously water demand has to be seen in light of other demands, growing urban demands, requirements for water to go downstream into Mozambique, etc. Just bringing the climate change, and I've only shown 2 of a whole multitude of climate downscaling options available. And I think that's one of the biggest problems when we talk climate change, is we have huge uncertainty. You can run 5 or 6 models and just look at the sort of variance within those models. It can be huge. The results can be very different, particularly as the rainfall. You eventually have a position where you can say almost nothing about it. But there are some trends that are fairly common throughout most climate modeling, and one of them, for instance, is the size of big storms. So though the rainfall might be reducing on average, you could be well in a situation where there's far less rainfall, but it's occurring in far more concentrated storms. And then just looking at the sort of direct sugar energy trade-offs, this is looking at 6 different scenarios. The top is the classic old sugar production scenario. You grew your sugar cane, you crushed it for sugar, you burnt the bagasse because it was just a waste product that you needed to get rid of, and you basically got a certain amount of sugar, and it works out about 125 kilograms of sugar per ton of cane. You can then start going towards the Brazilian model, firstly using the waste as either molasses moving to ethanol or the bagasse moving into electricity generation. And you can then ramp that up to a final at the bottom, producing just ethanol and electricity, not producing sugar at all. So there's a lot of trade-offs that can happen in that space. Ethanol as a fuel, I think some of you will remember how much there was sort of debate about ethanol production in South Africa. That was prior to the 2008 recession. The cost point was fairly good in those days. Suddenly the barrel price of oil dropped. Nobody wanted ethanol anymore. It would appear we're coming back to that position where it might be financially viable again. I tried to do a sort of break even, where would the ethanol price and the meet, so that on the bottom there is the price of producing ethanol, a litre of ethanol. On that axis is the pump price of fuel. The horrible point when you do this is you realize that for R8.50 of our fuel at this moment in time goes to taxes of 1 cent, one sort or the other. So a lot of the uncertainty is what taxes you put on the system. But even taking that into consideration, we probably are starting to meet that break-even point again, where moving to ethanol might actually not be a bad option. And then I think the main thing about this is really the decision support. How do you actually make this information available to policymakers? And we've spent a lot of time on working through this. Clearly, one of the big issues is the baseline data. And even in a very simple system like Swaziland, where we assumed the baseline data would be there, very accessible, getting the correct baseline data, getting it pulled together, proved exceptionally difficult. What we've moved towards is a spatially explicit tool, sort of using a GIS type of framework, able to drag and drop different land uses, instantly get feedbacks to all the different sectors from doing that. A scalable interface using basically a sort of Google Earth type interface, the sort of thing you're all used to with your GPSs or whatever else, where you can just zoom in infinitely and get more and more detail as you go into the process. Overlaying that, a very complex query builder, so you can ask really any type of question you want to about the different components in it, and then using a sort of cube type logic where you've got a spatial and a temporal aspects to your data, and obviously you could put in more aspects to your data. So that's just where we've been playing around. It's still work in progress, but this has been a hugely fun process, and we've learned a huge amount in the process. So just coming back at sort of some overall concluding comments on this, I think one of the key issues around the Nexus way of thinking is breaking the silos. It's around getting different departments, different sectors in government, in some cases even different sectors within the same department talking to each other. I think the big issue on that is it is around trade-offs. It's about making sound economic, sound social decisions, and clearly policymakers need evidence-based tools to help them make these trade-offs. Things like integrated assessment modeling, I think, are part of the equation, but as I was saying earlier, they typically work well at a global scale. What we've seen is at the sort of level of doing this in a sort of policy theatre type of framework, is you need to be able to have models that have run in the background, that produce data in the background, but you can't have them running in real time. So you've got to find novel ways of linking outputs from these models so that you can pick up some of these feedbacks without having hugely complex models in the background. And then obviously there needs to be ways of understanding the linkages, the feedbacks between the linkages, and eventually the policy instruments that might also be useful in changing decisions. So just some of the things that I think are quite important, and a lot of this has been discussed about in the last few days, but that's actually growing the envelope. The technologies we have where we can get more for less. It's a very classic example is the Working for Water program. Get rid of the aliens, make more water available, and a number of other benefits coming in, social benefits, biodiversity benefits. Growing the environmental envelope in crop water use efficiency. A lot of that's been said in the last few days. But clearly we can get more for less land use and more for less water use. Closing the yield gap, opening up land for cropping is a major driver of degradation in many parts of the world. Clearly there's parts of the world where there's a huge yield gap. Africa being a key example. Closing that yield gap is an important aspect. And then also, in many cases, looking outside of the food, water, energy sector. So, for instance, smart mining can have many feedbacks that would be hugely critical. If we can take out a seam of, say, gold-bearing rock that's only under a meter thick, rather than a huge tunnel that people can walk through, far less energy needed. You're not needing energy to cool if you're using smart technology. You're not needing energy to move that ore up and down in shafts. There's way less pollution, way less water use. So you can actually grow the food water use sector by reducing the water use in other sectors. This whole issue of the circular economy, not being wasteful, recycling, etc. And then, parts on this one I hate to say because I'm a great meat eater, but all the assessments that I've been involved in are suggesting eating of meat is actually hugely environmentally unsustainable at the global level. That's not saying that meat production isn't the best land use in many local situations, but globally about 30% of our cropland is going directly into livestock feedstock, and that's a very, very ineffective way of converting plant protein into human food. So just a few closing comments here. I think all of this is around long-term decision making, and it's around where decision makers should be investing, and that could be both government and the private sector. Where can they invest into the long term? And also it's equally important, where shouldn't they be investing? Where are the areas that are going to close up because of environmental problems? The climate's going to be no longer suitable. The amount of water going to energy means nothing's left for crop production, whatever else it has to be. And I think the other component of it is that the risk profiles change substantively as we move into the future as well. So thank you. That's just some thoughts.